Okay, now this is for your confusion to be taken out. Okay, just to erase your confusion, I have here the difference between the BPT and the converse of BPT. That is, basic proportionality theorem is on the upper side and its converse is on the lower side of the board. Okay, now see what is basic difference between these two is here the statement is if a line is parallel to a side of the triangle, one of the side of the triangle, and if that line divides other two sides into distinct points too, then the line divides those two sides in same proportion. So here given was like line L is parallel to a side of the triangle and it is intersecting other two sides into distinct points. This was given, and which is being asked for proof, that is nothing but we call it as two proof. So what was in two proof? It was the line L divides those two sides of triangle in same proportion. So the ratio which we have to prove to be equal. Like line L is parallel to BC, and then we got to prove that this ratio is equal to this ratio. Understood? Now, what is there in case of converse of BPT? Just shift this to the given part and this given to the to prove part of the theorem. Like I have written here, what will be the statement of the converse? It is like whatever there is in the statement of BPT after this word if, that will come in the case of BPT after then. And in this BPT, whatever the sentence was after then, it will come in the converse after if. Like here, what is the statement of BPT's converse will be? That is, if a line divides two sides of triangle in same proportion, if a line divides two sides of triangle in same proportion, means already they will give you that the ratio of the two sides is same, is equal. Okay, and then what is to be proved is then it is the line is parallel to the third side of the triangle. Okay, so given is this ratio equal, and to prove is that line is parallel to third side, that is BC. Okay, so this is basic difference. Since you have to solve questions in practice set 1.2 on these both the cases, that is of BPT theorem and there is converse of BPT theorem. Okay, now so you have to keep in mind that to use BPT, they will give you that line is parallel to one of the sides of the triangle, and they will ask you uh, to check whether the ratio of the two sides of triangle is same or not. Okay, and when you will use when will you use that converse of BPT? When they will give you that the ratio of two sides of the triangle is same, and they will ask you to show that line which is parallel to the third side of the triangle. Okay, so you have to understand that thing while solving the practice set and the examples. Okay, so this was basic difference, so keep in mind. Okay, now again let me clear your confusion about the theorem or the property of theorem of angle bisector and its converse. Okay, now see what we have seen already in the theorem of property of angle bisector is the bisector of an angle of triangle divides the side opposite to the angle in the ratio of remaining two sides of triangle. What does it mean is you will have that the ray CE is bisector of angle ACB. Ray CE is bisector of angle ACB. This you will have in the section of given, and then they will ask you to prove that it divides the side opposite to the angle, that is AE by EB, in the ratio of remaining two sides, that A, that is AE by EB will be equal to AC by CB. This you will have in the section of two proof. Okay, that means if they tell you to if it tell you that there is any ray in any triangle which is bisector of angle, and they will ask you that show that the bisector divides the opposite sides in the divides the opposite side in the ratio of remaining two sides of the triangle, isn't it? So this is how the theorem of property of angle bisector is. Now if you look into the converse, what is converse is, if in triangle ABC a ray CE such that it divides the side opposite to uh, any angle in the ratio of remaining two sides of the triangle, means there is ratio which is equal initially, then the ray CE is the bisector of the angle which is opposite to that divided side. Okay, it means you will have in the section of given that the ratio is equal already. You will have the ratio is already equal, and they will ask you to prove that the ray CE is the bisector. So if you found that the ratio is like this, then you can say that the ray CE is bisector of angle. Okay, just listen this carefully and just write it down. Just go through it for few more times, then you will come to understand. Okay.